Hello, friends, students, and enthusiasts. Welcome back to my channel once again. So today we are discussing one more project, but a little different. That is what is available in the market, or the ideas are floating in the market. Little different. So name of the project is a smart night light using LDR, okay, and OLED display. And using here we have used a microcontroller that is called as Pico-2. That is the microcontroller number is 2350. It's a simple project for students to understand who want to understand what is PWM, that is pulse width modulation. That is we also called as a dimming of LED or mutants. Okay, so this is our project. So let's see what is the objective. The project automatically turns an LED on when it gets dark. Simple project, and off when there is a sufficient light using a LDR. Light dependent, that is LDR is light dependent resistor. And Raspberry Pi Pico-2, please remember, we have not used Raspberry Pi Pico, that is RP2040. Here we have used 2350, RP2350. That is we call it the Raspberry Pi Pico. Project displays the light level on the SSD1305, that is screen is there, already screen is there, and smoothly adjust LED brightness using PWM. As the around environment gets darker, the LED gradually becomes brighter instead of simply turning on or off. Okay. So further improvement, what we can do, or we can apply our brains and can make it a little more improvement in this. That is, first idea is automatic room lamp using a relay module. We can add a relay to it, and we can control the appliances or light or lamp or whatever it is through a relay module. Second is OLED graph of light intensity over time. So here I have given a bar. When I will take you to the lab, I will show you. We can put a graph also. Third is Wi-Fi dashboard using Pico-2W. I have to change the IC. That is, I have to go for a Pico-2W. That is Wi-Fi, where I can make a Wi-Fi dashboard. It becomes IoT project. Or fourth is sunrise and sunset simulation using PWM fading. Okay. So fading also we can do it, but here also we have used fading in this case. But the visibility will be very, very less because the voltage and frequencies are a little different. Or anyhow. So battery powered solar garden light also we can add a solar light with this, and we can see the things up. Okay. So here I will just given a small example, like this is my board. This is my schematic diagram. In fact, this is OLED display, one LED light. I have shown red color light over here, and which will be controlled. That is the dimming and this thing. And this is my sensor. That is your LDR sensor. So it's very simple connection. How the connections are given. First of all, component required. Raspberry Pi Pico-2. That is one LDR 1. 10 kilo ohm resistor. If you are only using LDR without the module, then you have to use 10 kilo ohm resistor, which will be connected to the ground. Okay. SSD OLED display is there, which works on IPC. LED one, by any color you can use white, green, or whatever it is. This purpose. And 220 ohm resistor. That is the series. It is connected to the LED. Then battery or supply to adapter. Breadboard I can provide. On the bottom side, you can see LDR. That is the connection I've shown it here. That is connected to LDR connected to GPI 26. LED is connected to GPI 15. SSD OLED is connected to GPI 4 and 5. That is SCL and STA. Yes. So let's go to our lab and discuss more or see the things, how it works there. In our lab right now. So just we will discuss about the project. Okay. So right now you can see the light is off. Okay. And the LDR I have kept it. I have not used the module. You can use a module also. And on the display, LDR value, it is showing some, but it's continuously changing, and dark percentage and light percentage, you can see. So I will just put my hand. You can see gradually when the darkness enters, that is when it becomes dark, you will find that the increasing. That means night time, the light starts. Okay, as you can see there in the graph also, it is coming down. See, right? Okay, so the lesser light, more darker, and the maximum dark, the percentage goes up. Dark and LED percentage goes up. At that time, LDR values will come down. So I will just tell you, I will just show you exactly where we have to put the LDR values and how you can control. So first of all, whenever you do this project, so you have to count the LDR value so that correct configuration can be done for the light, that is PWM pulse configuration can be done. Okay, I hope you understood. So I will just explain you about the parts and all. So this is my Pico board. It's written over here, Pico-2. Okay, so it is working on MicroPython that already we have discussed. Two connection from here, that is pin number 4 and pin number 5, which is going to the OLED display. That is two connection, that is SDL and SCL. It works on 3.3 volts, which I have taken on pin number 3 over here, right? This is the pin number 3, and there from there I have taken the supply for this. LDR one end is connected to 3.3, another end, that is the junction point, I have given it to pin number 26, that is the analog one. Please remember, I have given it to analog. So PWM, this is very famous for this purpose. This works on I2C, MicroPython, right? Okay, and the analog of this thing is connected, it is analog, okay, and output is digital, okay. So sorry, PWM. So likewise, all the combination I'm just showing to you, okay. So the code in MicroPython we will discuss now. So I gave you the idea that how the connection has been made and all. Very simple connection. I've explained you the diagram also. Now we'll go to the code part. Okay. You can see I have opened. I've come to my Tawny ID. So first of all, there are two files over here that I'll be sharing both the files with you. The first file is SSD1306.py. Second is the main file. The main file is important. SSD1306 only for the display. Right. This is my display, which is coming, and it is for that purpose only. As I'll show you again, so you can see how it is working. Okay. So on this screen also, on that is shell module or your the screen is showing what is the values and all. You can see it's continuously going high, low, and as well as on the display also. Okay. So here these are the three libraries, that is machine pin, ADC, PWM, and I2C. These are the built-in libraries which we have taken. SSD1306 I have added separately, that I told you, this is 1306. Okay. So this library, this code also I will be showing. Both the code has to be loaded on the Pico port. That is your display. All right. So main PY, I have given the width of the SSD screen. Then you have details about that. Now ADC pin is set to 26. Here, this is important, the LDR minimum and maximum value. As I told you, when you put your hand, what is the darkest value, you check it, that is the minimum. And if you're using the light, exactly more light, maximum light, at that time, what is the, so you take the values, record it, and you put it minimum and maximum over here. So pin number 15 is PWM pin. Please remember, not all the pins are PWM. So you have to be very careful with that. Okay, the codes are here, that maximum minimum value multiplied by 65,535. That is the formula for the PWM. And percentage, if you find out, you have to multiply by 100. Okay, so smart light, what will be there on the OLED screen, it is given. And time speed is 0.01 according to your setting, that is LDR, and this thing you have to change the timing. So I've taken it as a 0.1. So it will be around about 0.1 to 0.5. Okay. So very simple code. Two files. Please remember that. Tawny ID. I've done it. If that is for the MicroPython. I hope you will like this project. If you have any questions or this thing related to this, please do ask me. Please do write to me. Right. Please, if you like the project or if you like the idea, please share with your friends. And thanks for watching. See you in the next talk. Thank you.